The most representative arts of the 20th century, such as cinema and photography, were made on supports derived from cellulose. Unfortunately, this is a chemically unstable material, which has caused the destruction of a large part of these cultural heritages, and it threatens their long-term conservation, due to the decomposition of nitrocellulose and the release of acetic acid from cellulose acetates, also called the vinegar syndrome. The European project NEMOSINE is developing a modular system for preventive conservation to avoid this problem.
NEMOSINE aims to improve the traditional storage solutions to preserve the 20th century cultural heritage based on cellulose materials such as films and photographs, by developing an innovative smart package with the main goal of energy saving and extend conservation time.
The system consists of a package that integrates absorbent acetic acid absorbents, sensors that detect these gases and those of nitrogen, and software that monitors these emissions and manages a degradation model to facilitate making decisions for the preservation of the materials thus conserved. The NEMOSINE package is made of polypropylene for its chemical resistance. It is inert and stable, a good water-vapor barrier, suitable for injection molding, and its price, a key factor for scale-up and commercialization. NEMOSINE has comprehensively characterized several grades of PP for injection molding, especially in terms of volatile organic compounds and phenols. To make sure that the packaging was safe for cultural heritage, this analytical characterization was also performed on samples injected with different process conditions and after thermal aging. The box also fulfills end users' requirements like physical resistance, stackability, dimensions, manageability, opacity, or different colors. Rheological and mold filling simulation have been carried out using MoldFlow software. The objective is to determine the pressure during the mold filling step with the polymer for each part of the box and according to the wall thickness. Mold design was realized for manufacturing. The NEMOSINE EU project has developed an acetic acid absorbent based on metal organic frameworks. MOFs can be tailored for the efficient absorption of acetic acid in the presence of humidity, which is the case of cultural heritage based on cellulose derivatives. The research is focused on hydrophobic MOFs that could lead to the control of acetic acid levels inside the boxes. The MOFs found displayed an enhanced selectivity towards this gas in comparison with other absorbers like zeolites and activated carbon. Consequently, MOFs should help the end users to prevent, detect, and avoid the vinegar syndrome degradation. The final MOF shape chosen for integration in the package have been granules for its mechanical stability and high absorption capacity. To facilitate handling, the MOF granules are sealed inside of Tyvek bags that must be placed on the grid set in the lid of the box. The trials carried out have demonstrated their efficiency. The NEMOSINE research on curative solutions has not found an antifungal product innocuous both for CH goods and human health. In case of fungus contamination, that grid can also be filled with a pouch containing silica gel to dry the damaged material and later replace it with a MOF pellets bag. The NEMOSINE project has created a sensing solution to detect acetic acid or nitrogen dioxide gases. To create a simple, low-cost, low-power solution to detect the degradation of cultural heritage artifacts based on cellulose acetate at early stages, metal oxide semiconductor sensors were chosen. For a sensing solution, which was accurate in detecting the target acetic acid and not be affected by other volatiles released by the cultural heritage artifacts, a two-sensors array was assembled and tested, first on pure volatiles and then on real film samples. A mathematical elaborator was created capable of calculating acetic acid concentration regardless of other volatiles present. A software with graphical interface was created, allowing the user to directly read both the raw values and the acetic acid concentration when the board is connected to the PC via USB. The system was successfully tested on more than 40 film samples, comparing the result obtained with those calculated employing the reference methodology acid detecting strips. To monitor the decay process, the NEMOSINE software includes a degradation model based on a multi-scale hybrid model that combines the gas's release data from the sensor and the user's item metadata.
NEMOSINE developed a new methodology in evaluating the degradation state of historical films and its evolution over time based on gas sensor data and user input information. We developed an extremely powerful tool based on hybrid modeling to determine the effect of each storage parameter like temperature, relative humidity, and the presence of an adsorbent on the film's lifetime. The tool gives the user guidance on the best preservation actions based on quantitative predictions to save energy and extend conservation time.
The users can set up an environment and create rooms and shelves, register the sensor nodes, and associate them to a room or a SPU where any risk alert will appear during the monitoring of the parameters. Users can also register new media, edit and search them by their metadata. On the other hand, the cloud application is managed by model makers, and measurements can be downloaded containing data submitted by archives and upload updated models. Thanks to the modularity of the SMART package, the sensors can be used for environmental control too, as their array is independent of the box.
NEMOSINE Consortium is composed by a total of 16 partners from all around of Europe. Research groups, film archives, and industrial partners working together to achieve an innovative solution for the preservation of film and photographs.
The effectiveness of the SMART package will make it feasible to increase life expectancy of the cultural heritage based on cellulose derivatives and its conservation even at room temperatures. Energy saving, pollution, and costs reduction are then later improvements of the innovative NEMOSINE project.